Hey guys, what's up? This is Manas and I'm back with a new tutorial on development of surfaces. So guys, this time around I'll be taking up a new object that is going to be a cone. So why wait? Let's begin with our problem number 1. And here it is. So it's based on a cone, and a cone having base 50 mm diameter and axis 60 mm long is resting with its base on HP. It is cut by a section plane perpendicular to the VP and inclined at 60 degrees to the HP and bisecting axis. Draw the development. So the object in this case is obviously a cone having dimensions in the form of diameter. Base diameter is 50 and axis length is 60 millimeters, and at the same time there is a condition that has been given to us, that is resting with its base on HP. Alright, now guys, just think about it. If a cone is resting with its base, that is a circular base, on the horizontal plane, then one thing is for sure, that the true shape of the base can only be seen from the top, and hence you have to begin by drawing the top view of the base. Alright, that's going to be, and that construction is going to happen below the XY line. Fine, let's move ahead and let's extract data regarding this cutting plane, okay, aka auxiliary inclined plane. That's what you call a cutting plane when it makes a certain angle with the horizontal plane, okay, and perpendicular to the vertical plane as well. The cutting plane is at an angle of 60 degrees, and at the same time it is bisecting this axis. Alright, now after this what we need to do is, now guys, you need to think about this. Now if you try to unfold the cone and flatten it up, okay, there is some kind of a pie kind of a portion which you're going to see. It resembles to that of a pizza. Alright, and it is going to make a certain angle, and that certain angle has to be calculated, and we have this formula for that: 360 multiplied by the radius of base upon slant height. Radius of base is obviously, the base diameter is 50, so radius is going to be 25. Slant height can be calculated by using this Pythagoras formula. Okay, on putting the values we get this as our final answer, that is 138.5. okay, fine, let's move ahead and let's start the construction. As I've already told you, we'll initially start the construction by making the top view, and for that let's have a reference line, that's what you call the XY line, below which I'm going to place a dot. Now this dot is what you call the apex, okay, the top view of the apex, and this is represented by point O, and with this as center and with radius as 25, we're going to draw a circle something like this. Next step, let us provide some dimensioning to this circle. Okay, so this is 555 is our representation for diameter. Now let's divide this circle into 8 equal parts. Fine, now let's start from this point over here, 1 2 3 4. Let's give all the points some names. Okay, so that's it, 1 2 3 4 5 6 7 and 8. Now guys, we have successfully drawn this top view, and now we want to create this front view. Alright, and for that we have to look at this object right from here. Okay, so the front view of 1 is going to lie here, 1 dash, then front view of 2 and 8 are going to strike over here, that is 2 dash 8 dash. Similarly, we have 3 dash and 7 dash over here, we'll have 4 dash and 6 dash, we'll have 5 dash over here. Alright, fine, let's write them down. Okay, now the axis height has been given to us, alright, and it's equivalent to 60 millimeters. So this is going to be 60. We need to go ahead, up ahead 60 millimeters. So this is going to be the axis, and now let us say that this point over here is the front view of the apex, that is O dash. Now let's join all these points, okay, with this apex. It should look something like this. Alright guys, that's done. Front and top view done. Next thing to do is to locate the cutting plane. So how can we do so? We know very well that the cutting plane is intersecting, or rather bisecting, this axis over here. If a cutting plane is bisecting this axis, that means one thing is for sure, that it is dividing this axis into 2 equal parts. That means 30 above and 30 below. So that is the point, and through this point, so this point actually is at a height of, from this point to this point, the height is 30 millimeters. Alright, so from this point we are going to draw a cutting plane, and it should look something like this, okay, at an angle of 60 degrees. That's it. Alright guys, now this cutting plane over here is intersecting the base, okay, as well as at the generators. This is also generator O3 O7, this generator is what you call O4 O6, and this generator over here is what you call O5. Okay, so we're starting from this point, it is cutting exactly at 2 and 8, and this is going to be A, this is going to be B. So A point is somewhere around O3, B point is somewhere around O7, then we have C, then we have D, C is somewhere around O4, okay, D is somewhere around O6. Then we have this point also, that is going to be E. Fine. Now we need the true length. For development we need true length. As I've already told you, you need to pick a generator. So right now we have as many as 8 generators, O1, O2, O3, O4 and so on. Out of these 8 generators, there is one such generator which is absolutely parallel to XY. So we can see clearly that O1 generator is absolutely parallel to this XY line, and hence its corresponding front view, that is O dash 1 dash, will show the true length. You can also say that O5 is also parallel to XY line. Okay, so O5 corresponding front view is also going to show the true length. So either you can take true length as O dash 1 dash or O dash 5 dash. Hence, so let's move forward. Okay, so the true length is O dash 1 dash, and let's move forward. Let's have a point A, big and bold, O point, and when with O dash 1 dash as the radius and with this guy O as the center, I'm going to put up an arc over here, something like this. This angle is going to be, guys, 138.5 as we have already calculated. Okay, on flattening up the cone, the angle it is going to subtend at the center or at the apex is going to be 138.5. Fine, let's move ahead, and this is going to be the overall pi. Okay, and let's have this point as 1, and now we need to divide this cone, this particular section, into 8 equal parts. Alright, it should look something like this, 8 equal parts. Alright, so initially you saw this overall angle over here, 138.5. You can bisect this angle. Angular bisection is pretty simple. Okay, so when you bisect this angle, it gets divided into 2 equal parts. Then pick up any one portion, okay, then divide it further into 2 parts. So 1 can be divided into 2, 2 can be divided into 4, and 4 can be made 8. Alright, that's how you need to go about your task. So these are all the division points, and let's name them one by one. This is going to be 2, 3, 4, 5, 6, 7, 8. Alright, so we have all the points. Okay, fine. Now guys, we need to start developing this in the best possible way. You can clearly see that this cutting plane over here intersects the base at 2 dash comma 8 dash. So at 2 and 8. So let's make point over here, and let's make a point here. So this is the point where our development is going to start, and it's going to end at 8. Alright, let's have the development for A and B. So A point is an O3 and B point is on O7. Alright, so but for that, what we need to do is we need to project this A dash B dash onto the true length, and it's going to look something like this. So this new point over here is going to be A1 dash and B1 dash. Alright, so now what you need to do is keep one leg of your compass here, other leg over here, then with O as center you need to put an arc, something like this, and this is going to be your point A. Alright, and again with that same radius we need to again put an arc over here along this O7 over here. Okay, so you're going to have point B. Fine, so let's repeat this process for obtaining C and D. So C is going to be over here around 4, and D is going to be here, that is along O6. So let's extend the line, let's produce a line from C, and it's going to intersect this true length over here. So this is going to be C1 dash D1 dash. So again, keep one leg of your compass here, other leg over here, then with O as the center, put an arc 1 over here. So this is going to be your point C. Put one more arc over here, and this is going to be, guys, your point D. Finally, we have this point E dash. So E dash is already on a true length, so doesn't matter. You can take this arc also, O dash E dash, or you can project it on the true length. Okay, so this is going to be same. If you take it as O dash E1 dash, you also have the option to go for O dash E dash. Both of them, or both the arc lengths or both the radiuses are going to be the same. Okay, now with O as center you need to put an arc over here. Please watch carefully. So this is going to be your point E. Alright guys, only thing left is to join all these points in the proper sequence with the help of a smooth curve, and finally it should look something like this. So that's the development of the cone over here. And now finally I need to tell you guys which portion is to be darkened and which is to be left as it is. So initially all the drawing that we have made can be carried out with the help of a 3H pencil, and finally the portion which is to be darkened should look something like this, and it has to be carried out with the help of an H pencil. That's it. So this portion you see over here below the cutting plane, okay, has to be darkened. So this is the portion, all right, which has to be darkened. All right guys, so that was all from my side, and if you have any doubts, any queries, feel free to ask. Write them down in the comment section below. I'll try to answer them in the best possible way and as quickly as possible. So guys, join us again to learn more about engineering drawing, and do subscribe. This is Manas Patnaik signing off. Take care, have a great day, and keep drawing.